Hi folks. Okay, so for today we're going to have a little bit of fun and we're going to build a nightlight circuit inside TinkerCAD and we're going to demonstrate that working. Okay, so from the starting screen we're going to click Circuits and we're going to create a new circuit. And I'm going to try to leave both screens open here so that we can get a better sense of what's going on. Now the first thing we're going to need is a breadboard. I'll use this small one here. If you decide you need larger ones, I still encourage you to use the ones that have the color coding built in. Okay, and that'll help us with arranging our power and our ground effectively. Okay, so let's throw power to our board first. Of course, if you were building a real circuit, the last thing you do is connect power, but we'll do this first in a simulation because there's no risk of harming components. Now while we're working, we're going to make sure that our wires are color coded appropriately. This helps us to troubleshoot our circuit later. And even though when you build your first circuit in real life, this will seem like a lot of work, the first time you have to cut all these wires, it's worthwhile. Resist the temptation to say, oh, this is just for my practice, so I'm going to use any color I want. Try to color code your wires to communicate what they're doing. This will help you prevent things like short circuits. Okay, you see what I've done here. I've connected the ground on one side of my board to the ground on the other side of the board so I can use either side. And I've done the same thing with hot. Because I only need one voltage level, I simply connected those together so I can work from either side of the board. So now I've got my power supply hooked up. Now I can work any way I want. I will tell you that I prefer to lay things out geographically, much like the schematic. I also tend to want to work clockwise as I work through my circuit so I don't miss any connections. Okay, so how would this look in this case? Well, what we can do is we can take our resistor and say, okay, our resistor's connected to hot. Okay, good enough. So we go and we look for our resistor component, there it is, and we connect that to hot. Notice it's in the upper left-hand corner like in my schematic. But my resistance isn't correct, so I'll make this 100 kiloohms like the circuit says. Okay, so there's our 100 kiloohms. Now, any component has to be connected to at least two things. In this case, our resistor is connected to hot here, so this connection is correct. But then it needs to be connected both to the base of the transistor and to the LDR. Well, so there's a lot of different ways we can do this, but let's first just start with the LDR. So TinkerCAD calls this a photoresistor, and we can connect our LDR just like this. Now you notice one end of the photoresistor is now connected to the end of our resistor. The other end of the photoresistor, so everything has to be connected to two things, the other end of the photoresistor needs to be connected to ground. So we can go ahead and simply connect ground to the other side of that photoresistor. There we go. And make sure, of course, that our wire is black. So now we've got our photoresistor connected to black, but notice that this resistor was supposed to also be connected to our base of our transistor. So let's go ahead and place our transistor now. Notice that it's placed across 3 different locations. This will make it useful for us. And then we have to verify on our data sheet that the center pin is the base and run a wire to our center pin. Now this wire isn't hot and it isn't ground. It's neither of those things. So we should use a different color to communicate this. Green is okay. I like to use variants of red for this because it's in fact a positive wire. So I'll use something like orange. If you notice, this can either be 0 or positive. it can't really be anything else. So I'll typically use orange. Now, we have this connection done, this one, the resistor, and this connection. So you can see we've got a long way towards what we need to do. Working clockwise through, we can see the next thing we see is a resistor connecting positive. So we can go ahead and connect up a resistor to positive. Let's go get a new one. Drop it in. And 1,000 ohms. Uh-oh, this isn't 1,000 ohms. Well, if you can remember unit conversions, you can see that 1,000 ohms and 1 kilo ohm are in fact the same thing. So this will do just as it is. So our resistor is now connected to positive, but everything has to be connected to two different things. Okay, well, what else is it supposed to be connected to? Well, in fact, it's supposed to be connected to an LED. So our LED is here, and we can drop our LED in place. However, remember an LED is a polarized component. So we need to flip it around and put the long wire towards positive, like we've done here. Now we've got this connection correct. Okay, the next thing after the LED is our transistor. So we need to connect up our LED to our transistor. Okay, drag a wire, and there we go. And this wire is also somewhat positive. You can argue that one, but we can just simply choose any color that isn't the other ones. So there's our connection of our LED to our transistor. Now we just have to ground our transistor and our circuit is complete. So to ground our transistor, we would normally use as short a throw as possible. So we'd put a short black lead up across here. However, I want you to be able to see this very effectively. So let's run it downward instead. Ground it through here and make sure our wire is black. And we would pause at this stage, especially in real life, to check to make sure that all of our connections are correct so we don't burn out any components. And we can do this very simply. All we do is walk our way through checking each one of these leads. So power, etc., all the way through. Since this is a simulation, I'm not worried about burning out components. I'm just going to go ahead and connect power to my circuit. And I can see that my LED lights up. Now we have to stop for a second and think about the logic of this. Well, a night light should be showing the LED turning on when it's dark outside. Well, let's check the setting of the LDR. The LDR right now thinks it's dark out. If we make it light outside, in fact, our LED turns off. So our circuit is working perfectly. Hooray for us. Thanks very much. Have a great night.